So let's take an example. A group of rats are split in two. One group is sent on a space flight while a control group are held in the same conditions but not sent on the flight. So we've got our two populations. For both groups, the red blood cell mass was measured. There's 14 subjects in each group, and these are the scores for the red blood cell mass. So the theory is that the conditions of spaceflight will cause a change in red blood cell mass that'll have some physical effects. If that's the case, the red blood cell mass for the flight group on the left should be significantly different from the red blood cell mass of the control group on the right. So that's our theory. What's our null hypothesis? Our null hypothesis is always the equality. So the null hypothesis is that the flight has no effect, that there is no difference between the blood cell mass of the rats who went on spaceflight and the rats who stayed at home. So we do the computations for that exercise. We take our formula for the t-score and we apply our numbers. The mean of the first group is 7.88. The mean of the second group is 8.43. The hypothesized population mean difference is 0. And you can see that the mean of the standard deviation of the first group is 1.017, simple calculation. The standard deviation of the second group is 1.005, and there are 14 items in each subjects in each group. So you can see there straight away that with a one group of 7.88 and a mean for the other group of 8.43, initially you might suspect from a casual browse of the data that there is a difference between the red cell blood mass of the two groups. But the question is whether it's significant or not. So what we've got, when we do that, we calculate the t-score to be 1.437. Remember, this is a two-tailed test, so we're interested in both ends of the distribution. That point being that we don't care if the difference means that the space rats could have much higher red blood cell mass, which is on one side of the distribution, or they could have much lower. Either would be a result. So we want to find out that there's a big difference between them. That means we have to be in the rejection area out on the right limb or the left limb of the distribution. Because at the center, we're going to not reject our hypothesis. We've got a score of 1.437 on t-distribution, so we follow our test technique we've used a couple of times before in similar circumstances. We get a table and we look up the table. And here we have the t table, which has been provided to you in the notes. And you can see, as usual, it's got along the top the significance levels. Alpha equals 0.1, 0.05, 0.025. And you can see there's level of significance for directional tests, that's a one-tailed, and also level of significance for non-directional tests, or two-tailed. So we want to be in the column for the 0.05 column. Alpha equals 0.05. That's our alpha we've set, 0.05. So, and the rows then are degrees of freedom. So that's basically the number of items in the test. And so you count up the two samples and you deduct one for each sample. So 14 and 14 is 28 minus 2. There's slight differences for populations with unequal variances, but this is simple. This is a basic introduction, and that's enough for us. So we've got a degrees of freedom of two populations of 28 minus 2 is 26. So we're on the 26th row. And we look for our 1.437 on that row. And we find it just about here. So 1.437 is somewhere between 1.315 and 1.706. We don't need to know exactly where it is. We just need to know which column it's in. It's somewhere between those two columns. And what we want to do is we want to read off a probability store. So we go from the row and we get a column heading. The column headings are the alpha scores and they're also the probabilities. So we can see that we read up here and we're somewhere between a probability of 0.2 and 0.1. And we want to be at the column called 0.05. So our level of significance is way out. That means we're inside the non-rejection zone. So p-value is between 0.1 and 0.2. That means the p-value is definitely greater than 0.05. We do not reject the null hypothesis. So not rejecting the null hypothesis means that the rats have do not have a significantly different blood mass, and spaceflight has no effect.